Hello students, how are you all? Hope you are doing well. Welcome to the fourth part of System of Particles and Rotational Motion. Today we are going to solve numericals based on angular momentum and rolling motion. Let's get started. In the previous session, in the third part of System of Particle and Rotational Motion, we did solve numericals up to 68. Let's start with question number 69, which is based on angular momentum. Question number 69. Okay. A solid sphere is rotating freely about its symmetric axis in free space. Okay. What is the meaning of symmetric axis? Axis passing through center of mass along the diameter of the solid sphere. That is the meaning. The radius of the sphere is increased, keeping its mass same. Okay. Which of the following physical quantities would remains constant? Very good. So the very first point I would like to give you before solving questions based on angular momentum. So that is torque relation with respect to angular momentum. That is tau is equal to dl by dt. So in this case, majority of the numericals we are going to solve based on conservation of angular momentum. What's the meaning of conservation of angular momentum? If net torque acting on the system is equal to 0, angular momentum is going to be remains constant. So which can be replaced as initial angular momentum is equal to final angular momentum. So this is an axial vector. So it is represented like this. So this is going to be conserved. That means initial and final angular momentum is the same in the sense angular momentum is conserved. So most of the questions we are going to get from this two formulas only. Two formulas in the sense here torque is equal to dl by dt and initial angular momentum is equal to final angular momentum if net torque acting on the system is equal to 0. Now in this question number 69, they said the radius of the sphere is increased by keeping its mass same. That means they are changing radius. Are they applying any external force, rotational force? No, they didn't. Then what is going to be external torque acting on the system? It is 0. Then L is going to be constant. Which option matches here? Option D is the correct answer. Super. Next, question number 70. That's all, that's the answer. Question number 70. Question number 70. Two disks of same moment of inertia rotating about their regular axis, passing through center and perpendicular to the plane of disk has angular velocities omega 1 and omega 2. Okay, let me represent the diagram. They said two disks of same moment of inertia. So let me represent that. Axis is passing through center of mass and perpendicular to plane of these bodies. Okay, so this is how it is represented. So moment of inertia is I. So moment of inertia for this object is also I. But they are rotating with different angular velocities, that is omega 1 and omega 2. Super. Next, they are brought into contact face to face, coinciding the axis of rotation. Try to understand. Now these two disks are brought into contact so that axis of those two objects is coinciding. This is how they are placed. Can you understand the diagram? So very good. So let's say this is the first disk and this is going to be second one. They are placed on one by one. Okay, super. Then what happens to angular velocity? Angular velocity is going to be changed. Let me represent that omega simply. Moment of inertia is going to become I is equal I1 plus I2. That means I1 is moment of inertia of the first body. I2 is moment of inertia of the second body. Then moment of inertia of these two objects will get added up. It's like a mass added in linear motion. Super. Now new moment of inertia is 2 times of I. Hope you understood. Now what's the question they're asking? the expression for loss in energy during this process. Why they are saying there is a loss in energy? So just now I told that. So am I using any external torque to place one disk on the another disk? No, I'm not using any external torque. Torque is nothing but a rotational force. So such kind of rotational force is not being used here. So external torque acting on the system is equal to 0. If external torque is equal to 0, angular momentum is going to be constant. If angular momentum is constant, angular momentum formula for a rigid body is I into omega, and one more thing, I is inversely proportional to omega. In this case, moment of inertia is increased because of adding one more disk. Then what happens to angular velocity? Angular velocity decreases. That is the reason they are asking loss in kinetic energy. They are saying loss in energy as they are rotating. What kind of energy they will be having? Kinetic energy only. Okay, first of all, let me find out final angular velocity. So to find out final angular velocity, we know that L is constant, right? Here there is no external torque acting on the system to place one disk on the another disk. That is the reason external torque is equal to 0. As external torque is equal to 0, initial angular momentum is equal to final angular momentum. Initial angular momentum in the sense, initially two objects are there, that is I into omega 1 plus I into omega 2. Final angular momentum is 2 times of I, as there are two disks, into omega. So I will get cancelled out. Then final angular velocity after adding those, after placing one disk on the other, it is going to be omega 1 plus omega 2 by 2. This is the final angular velocity. Okay, so let me represent initial kinetic energy of the system. Initial kinetic energy in the sense, initially two disks are there and they are rotating with different angular velocities. Even though moment of inertia is same, let me represent that 1 by 2 I omega 1 square plus 1 by 2 I omega 2 square is the initial kinetic energy of the system. Let me write final kinetic energy, which is equal to 1 by 2 into final moment of inertia is 2y, and final angular velocity is omega 1 plus omega 2 divided by 2 whole square. Super. I need loss in kinetic energy. So initial kinetic energy is greater than the final kinetic energy here because finally angular velocity is reducing. So loss in kinetic energy is equal to initial kinetic energy minus final kinetic energy. What's the initial kinetic energy? 1 by 2 I omega 1 square plus 1 by 2 I omega 2 square minus this 2 will get cancelled out. I into, so this 2 will comes outside, that is 2 square by 4. Let me expand this. It is going to be omega 1 square minus 1 I by 4 omega 2 square minus I by 4 2 omega 1 omega 2. This is what the formula we are going to get. So this is the formula we got, loss in kinetic energy. Let's cancel out or let's add. So whatever it is possible we can do. One thing I can do is I by 2 is common in all the terms. So common one I by 2. So now I'm left with omega 1 square plus omega 2 square minus omega 1 square by 2 minus omega 2 square by 2 minus I by 2 is common. So omega 1 and omega 2 will be there. So that is omega 1 into omega 2. So from this again I by 2 into these two, subtract this 2, omega 1 square minus omega 1 square by 2. It is omega 1 square by 2. These two plus omega 2 square by 2 minus multiply it with 2, divide it with 2, omega 1 and omega 2. Again common 1 by 2. We are going to get I by 4 omega 1 square plus omega 2 square minus 2 omega 1 into omega 2. It looks like a minus b whole square formula. Omega 1 minus omega 2 whole square. This is the answer. This is the loss in kinetic energy. Which option matches? 1 by 4 I by 4 into omega 1 minus omega 2 whole square. Option A is correct. So that is the way we need to answer this kind of question. So next one, question number 71. Super. Two rotating disks A and B of masses m and 2m with moments of inertia Ia and Ib have equal kinetic energy of rotation. Let me write down the data whatever they have given. So there are two objects A and B, they are rotating. Mass of A is m, mass of B is 2m. Super. And moment of inertia of A is Ia, moment of inertia of B is Ib. Okay. And one more hint they have given, moment of inertia of Ib is greater than moment of inertia of Ia, have equal kinetic energy. Super. So kinetic energy of A is equal to kinetic energy of B. That means 1 by 2 Ia omega A square is equal to 1 by 2 Ib omega B square. Super. What's the question they're asking? They're asking if LA and LB be their angular momenta respectively, then they're asking LA and LB relation. Super. 1 by 2, 1 by 2 will get cancelled out here. What's the formula for angular momentum in terms of moment of inertia and angular velocity of a rigid body? It is L is equal to I omega, right? Okay. Let me find the answer. So from the given data, we can write down omega A divided by omega B whole square is equal to Ia by Ib, right? Very good. Let me relate this with respect to angular momentum. LA by LB is equal to Ia by Ib into omega A by omega B. From this, we can write down omega A by omega B as root of Ia by Ib. Let's substitute that in this equation. So this is LA by LB is equal to Ia by Ib into root of Ia by Ib. Super. A small mistake in this substitution. Here we have Ib and this is Ia. In reverse we wrote this. So this is going to be Ib and this is Ia. Inverse relation we are going to get. Ib, Ia. So it is Ib and Ia. Ib, Ia. So send this Ia by Ib right side. What we are going to get? Root of Ib by Ia into Ia by Ib whole square. Or else we can write down this as squares. Ia square, Ib square. Ib, Ia will get cancelled. Finally, what we are going to get? Root of Ia by Ib. So one hint they have given is that is Ib is greater than Ia. Then this relation is going to be less than 1. Then LA is generally less than LB or LB is greater than LA. Which option matches? Option C is the correct answer. Very good. Next question number 72. Two disks are rotating about their axis normal to the disks and passing through centers of the disks. So D1 and D2, D1 has 2 kg mass and D1 has 2 kg mass and 0.2 meter radius and initial angular velocity of 50 radian per second. Super. Look at the data they have given. So this is disk D1 and this is disk D2. So they gave initial angular velocity of disk D1 as 50 radian per second. Disk D2 has 4 kg mass, 0.1 meter radius and angular velocity of 200 radian per second. The two disks are brought in contact face to face. Super. Earlier I did already represented, so these two disks are placed like this so that their faces are they are in contact with face to face. Okay, now what's the question they're asking? They're asking final angular velocity of the system. So this is how it is rotating. I need final angular velocity. Okay, so is there any external torque acting on the system? External torque acting on the system is 0 to add that at the two disks. So angular momentum is going to be constant, right? So this question is also again based on law of conservation of angular momentum. Super. So initial angular momentum is equal to final angular momentum, that is I1 omega 1 plus I2 omega 2 is equal to I3 omega 3. So I1 and I2 are the moment of inertia of the first disk and second disk. I3 omega 3 is the moment of inertia and angular velocities of the third disk. Third disk is a combination of 1 and 2. Okay, now very good. So what's the moment of inertia of a disk? How to find out moment of inertia of a disk? It is mr square by 2, right? So it is m1 r1 square by 2 into omega 1 plus m2 r2 square divided by 2. What is the value of m2? m2 r2 square divided by 2 into omega 2. Later I will substitute the values. I3 is nothing but I1 plus I2 into omega 3. So because we are adding two disks, that's the reason moment of inertia of the system increases, which is equal to I1 plus I2. So this is what I1 is. I1 is mass of the object is 2 kg, radius is 0.2 meter square, in the sense it is going to be 4 into 10 power minus 2 divided by 2 into W1 is 50 plus M2 is 4 into 10 power minus 2, not 10 power minus 2. Mass is 4 kg, radius is 10 power minus 1 square is 10 power minus 2 divided by 2 into omega 2 is 200, which is equal to I1 plus I2. So I1 is this value. Let me find out I1 first. This is I1. 2 will get cancelled. 4 into 10 power minus 2. Okay. 4 into 10 power minus 2 plus, so this is I2. This is 2 into 10 power minus 2 into omega 3. So this minus 2 is taken as a common. So minus 2 will get cancelled out. Now 4 5s are 200 plus 2 1s are 2 2s are 400, which is equal to 6 into omega 3. then 6 omega 3 is equal to 600 and omega 3 is equal to 100 radian per second. So this is answer. Which option? Option B is the correct answer for 72. Very good. Next, let's move on to the next question. Question number 73. Observe the given data carefully. A circular platform is mounted on a frictionless vertical axle. Its radius is r is equal to 2 meter. Observe this diagram. Whatever the question they have given, I did represent it in the form of diagram. They said circular platform is mounted on a frictionless axle. This is axle. This is a supporting rod. Okay. Radius is 2 meter. Okay. So radius is 2 meter. Next, moment of inertia about the axle is 200 kg meter square. Okay. So moment of inertia is given 200 kg meter square. Next, it is initially at rest. That means angular velocity of the disc is 0 initially. Okay. Next, a 50 kg man stands on the edge of the platform and begins to walk along the edge at a speed of 1 meter per second relative to the ground. Okay. So this person starts walking with a velocity 1 meter per second. Okay, so along the edge they said with a speed of 1 meter per second, which is related to the ground. This is velocity of this man with respect to ground they have given, which is equal to 1 meter per second. Okay. Next, the time taken by the man to complete one revolution is super. This question is solved with the help of relative motion. If you observe one point, if this man is moving in this direction, whatever shown, then disk will definitely rotates in the opposite direction, isn't it? Is there any next external torque acting on the system? No, it is not. External torque acting on the system is 0. External torque acting on the system 0 in the sense you are not at all applying any force on the disk to rotate, right? If you apply external force to displace that, rotate that disk, then that is going to be considered as a torque. Then angular momentum is going to be remained as a constant, right? Okay. Then initial angular momentum is equal to final angular momentum. One point they said is initial angular velocity of the disk is 0. So initial angular momentum is equal to 0. If initial angular momentum is equal to 0, final angular momentum is also 0. It means angular momentum of man is equal to angular momentum of disk. These two are in same in magnitude, opposite in direction. That is the meaning. Angular momentum of man and angular momentum of disk must be same. Those are in equal in magnitude, opposite in direction. So that is the meaning of final angular momentum is also 0. Super. What's the angular momentum of a man? Man of mass. What's the mass? It is 50 kg man. Super. So for a point mass, angular momentum about its axis is mvr, which is equal to I omega. Super. So which is found as, let me represent the values of omega, or let me find out omega from this given data. Omega is equal to, what's the mass of that man? Mass of the man is 50, velocity is 1, radius is 2, divided by moment of inertia of the system is 200, 50 ones, 54s. Answer is going to be 1 by 2 radian per second. This is going to be angular velocity of the disk. Angular velocity of the disk. Okay, super. Okay, so I know angular velocity of the disk. If I know, let me find out angular velocity with respect to angular velocity of the person with respect to disk I need. Okay, we know the formula, relative velocity formula. So relative velocity VAB is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Now, the same formula you can apply with respect to rotational angular velocity also. Angular velocity of A, I mean here man and disk, right? Let me find out. Angular velocity of man with respect to disk is equal to angular velocity of man with respect to ground minus angular velocity of disk with respect to ground. Okay, I need to find out angular velocity of the man with respect to disk, right? Super. What's the angular velocity of the man with respect to disk? I know linear velocity, they gave linear velocity, right? How to find out angular velocity of the man with respect to ground? Relation between linear velocity and angular velocity is V by R. So that is 1 by 2. Angular velocity of man with respect to ground is 1 by 2 radian per second. Super. This is angular velocity of the man with respect to ground. So what is this? The angular velocity of the disk with respect to ground, right? This is angular velocity of the disk with respect to ground. So but these two are in opposite direction, right? So assume this is in anti-clockwise direction and this is going to be in clockwise direction. They are in opposite direction. That is the reason we are going to represent with positive. So man with respect to ground, I am going to take it as positive, that is 1 by 2 minus disk with respect to ground, it is going to be taken as negative because it is in opposite direction, 1 by 2. So final answer 1 by 2 plus 1 by 2, which is equal to 1 radian per second. This is angular velocity of the man with respect to disk. So in relative terminology, now relative terms, which is at rest and which is under motion. Disk is treated as rest. So this is where, so I have to find out angular velocity of the man. Disk is at rest position. That's the concept of angular velocity. In relative terms, disk is at rest position. Now only man is rotating with an angular velocity 1 radian per second. So time taken to complete one revolution, t is equal to 2 pi by angular velocity of the man with respect to disk. Angular velocity is 2 pi divided by 2 pi divided by angular velocity of the man with respect to disk is 1. Answer is going to be 2 pi radian per second. Try to understand this. So go through this once again, then only you can understand. So answer option C is the correct answer. Very good. Let me solve question number 74. In question number 74, a circular disk of moment of inertia it is rotating in a horizontal plane. Super. 74. Let me represent the diagram. So it is rotating about a horizontal plane. Moment of inertia is given as it. Okay. So moment of inertia is it. Okay. About its symmetry axis with a constant angular speed omega initial. Constant angular speed omega initial. Another disk of moment of inertia IB is dropped coaxially onto the disk. Super. So let me consider another disk which is dropped onto this disk. So what is the moment of inertia of the first disk? It is it. Moment of inertia of the second disk, it is IB. Okay. Super. This is new disk. Okay, this is how it is represented. Next, what is the question they're asking? Initially The second disk has zero angular speed. Okay, no problem. Eventually, both the disks rotate with a constant angular speed omega final. Super. This is going to be omega final. Now, energy lost by the initial rotating disk to friction is. If you observe the options are in the form of IT, IB, and only omega initial. It means I have to find out the value of omega final. We know that there is no external torque acting on the system which is equal to 0, and angular momentum is constant. If angular momentum is constant, initial angular momentum is equal to final angular momentum. Initial angular momentum is it into omega initial, which is equal to final angular momentum it plus ib into omega final. Hope you understood the representation. So final angular velocity is equal to omega final is equal to it into omega initial divided by it plus ib. This is final angular velocity of the disks after adding those disks on the another. Okay. Now I need to find out loss in kinetic energy. First of all, let me write down initial kinetic energy, that is 1 by 2 I1 omega 1 square, which is equal to 1 by 2 I1 is it omega initial square. Now final kinetic energy is 1 by 2 I2 omega 2 square, which is 1 by 2 I2 is it plus IB omega 2 square. It is it omega initial whole square divided by it plus IB whole square. So it IB will get cancelled out. So final kinetic energy is equal to 1 by 2, or it is represented as it square omega I square 2 times of it plus IB. Super. Now I need loss in kinetic energy. So loss in kinetic energy, which is equal to initial kinetic energy minus final kinetic energy. What's initial kinetic energy? 1 by 2 into it omega I square minus final kinetic energy it square omega initial square by 2 times of it plus IB. Okay. So let's common it by 2. it by 2. Now we are going to get it omega I square plus IB omega I square minus it omega I square by 2 we are going to get, right? Super. No, we are not going to get any 2. So in the denominator we are going to get it is it plus IB. So it omega I square will get cancelled out. Now I'm left with an answer 1 by 2 into it IB omega I square divided by it plus IB. I think option D is the correct answer for question number 74. Yes, it is correct answer. For question number 74, option D is correct. Very good. Let's solve question number 75. Question 75. A thin circular ring of mass M and radius r is rotating about its axis with a constant angular velocity omega. We know what is the meaning of its axis. Its axis in the sense axis passing through center of mass and perpendicular to the plane of the body. This is how it is. It is rotating with omega, mass m, radius is smaller. Very good. Next, two objects each of mass small m are attached gently on the opposite ends gently to the opposite ends of the diameter of the ring. Super. Now what they are doing, they are trying to place two masses on the opposite ends of the diameter of the ring. Okay, so let me represent that. So they are placed on the opposite side of the diameter. So one of the mass is small m, another mass is m, like this. Okay, they are placed along the opposite diameter. Okay, now what's the question they are asking? The ring now rotates with an angular velocity. They said these two masses are placed gently. Let's say this is omega 2. Now, what happens to moment of inertia of this complete system increases, right? This set, this is placed gently, so external torque is equal to 0, angular momentum is constant. If angular momentum is constant, initial angular momentum is equal to final angular momentum. So initial angular momentum is I1 omega 1. Final angular momentum is I2 omega 2. So let me represent initial angular momentum. So that is I1. I1 is equal to mr square. What about I2? I2 is moment of inertia of the ring plus moment of inertia of these two masses. It is 2 times of mr square. If any mass is at a distance smaller and rotating about an axis, then its moment of inertia is equal to mr square, right? Very good. So let's represent that. So from this, what is omega 2? Omega 2 is equal to I1 omega 1 divided by I2. So what is I1? I1 is mr square. Omega 1 is omega by I2 is r square is common. You are going to left with m plus 2m. R square will get cancelled out. Then omega 2 is equal to m omega by m plus 2m. Which option matches? M omega by m plus 2m. Option D is the correct answer for question number 75. Let's try question number 76. Question number 76. A round disk of moment of inertia I2 about its axis perpendicular to its plane and passing through center is placed over another disk of moment of inertia I1. Super. First let me represent I1, which is rotating about its axis. Moment of inertia of this disk is I1. Okay, on this disk, okay, rotating with angular velocity omega about the same axis, the final angular velocity of the combination they are asking. Initially, so the disk which is having moment of inertia I1 is moving with an angular velocity omega. On that disk I2 is placed. Try to understand that line carefully. A round disk of moment of inertia I2 about its axis perpendicular to center to its perpendicular to its plane and passing through its center is placed over the another disk. On this I1 disk, on this first disk, another disk is placed whose moment of inertia is I2. So moment of inertia of the first disk is I1. Now I need to find out angular velocity of this combination. So we know that again torque is equal to, is torque is 0 or non-zero? Torque is equal to 0. Then angular momentum is equal to constant. Initial angular momentum is equal to final angular momentum. So I1 omega 1 is equal to I2 omega 2. Instead of writing like this, you can write on I initial omega initial, I final omega final. It is better. So I initial is I1, omega 1 is omega, I final is I1 plus I2, omega final is omega 2. Omega 2 can be represented as I1 omega divided by I2 plus, sorry, I1 plus I2. So which option matches? Option C is correct, right? Check out this option. Option C is correct. Question number 76. Is it clear? Very good. Let's solve question number 77. It is similar to 75, I guess. Let's try. A thin circular ring of mass capital M and a radius smaller rotating about its axis. Understand the meaning of its axis. I have already given a hint in lecture number 3 of system of particles and rotational motion. The meaning of its axis I have already given. With a constant angular velocity omega. Super. So 77. A ring of mass capital M and radius smaller is rotating about its axis, which is perpendicular to the plane and passing through center of mass, and this axis is rotating with an angular velocity omega. Next, four objects each of mass small m are kept gently onto the opposite ends of two perpendicular diameters of the ring. Super. Now four different masses are not different masses, four objects of equal masses, they are placed on the opposite ends of the diameter. Super. Let me represent, this is one diameter and this is the another. So mass small m, so this is also small m, small m, small m. Each mass is at a distance of radius of this circular path, right? Observe this diagram. So those masses are placed at the ends of the diameter of this ring. Radius is r. That means each mass is at a distance of smaller from the axis of rotation. What is the question they're asking? They're asking angular velocity of the ring. Again same. External torque acting on the system is equal to 0. These masses are placed gently, so angular momentum is constant. Initial angular momentum is equal to final angular momentum. Initial angular momentum is I1 omega 1. Final angular momentum I2 omega 2. So here it is. I1 is equal to mr square. They said it is a ring, right? Okay. So that is the reason it is mr square. What about this? I2 is not going to be mr square. Moment of inertia of the particles of small m, their moment of inertia is also added. This is mr square plus 4m small r square. Let me substitute it here. M r square, omega 1 is omega. It is I2 is going to be m r square plus 4m r square into omega 2. So this r square will get cancelled. R square will get cancelled. Then omega 2 is equal to m omega divided by m plus 4 small m. So this is angular velocity of the final system. Which option matches? M omega by m plus 4m. Option B is the correct answer for question number 77. Let's move on to the next question. As a disk is rotating with an angular speed omega, if a child sits on it, what is conserved? Again, net torque acting on the system. So the child is made to sit on the disk. He is not applying any rotational force. That's the reason angular momentum is going to be constant, because tau external torque is 0, right? So angular momentum is equal to constant. Hope you understood. So angular momentum of the system is constant. Our next concept is rolling motion. It's a very, very important concept and confusing concept also. I'll try to make it easy, try to understand. So I did already explain you about kinetic energy of a rolling body. So kinetic energy of a rolling body, in the sense it will be having translational kinetic energy and rotational kinetic energy, right? So first of all, a note. What about translational kinetic energy formula? Translational kinetic energy is equal to 1 by 2 mv square. Rotational kinetic energy 1 by 2 I omega square. This is only translational. Next, rotational. There is one more motion, that is rolling motion. This is also called as slipping, right? So this is a slipping motion and this is spinning motion. Next, rolling motion. In rolling motion, total kinetic energy is equal to translational kinetic energy plus rotational kinetic energy, which is called as rolling motion. Okay. So, and one more point that we need to understand is radius of gyration. That is k is equal to root of I by m. Remember this formula. So based on this only we are going to solve numericals. This is radius of gyration. In part 3 I did explain you about radius of gyration, rotational kinetic energy, translational, and what is the exact meaning of these three types of motions. I did explain. Just go through the part 3, then you will understand. Let's solve numericals. Question number 79. A disc of radius 2 meter and mass 100 kg rolls on a horizontal floor. Super. Question number 79. Disc is rolling on a horizontal floor. So it is rotating. It's a disc, right? So what's the radius of this disc? It is 2 meter. Mass of this disc is 100 kg. What is the question? Its center of mass has a speed of 20 centimeter. Okay, center of mass is also having a speed which is 20 centimeter per second. How much work is needed to stop it? Okay, super. How much work is needed to stop it, in the sense we need to use work energy theorem. Work energy theorem is nothing but final kinetic energy minus initial kinetic energy, or initial kinetic energy minus final kinetic energy. See, whatever the energy it is having, I have to give exactly energy, same amount of energy, but I have to apply force in the opposite direction of motion of the object. That's the reason object is going to be come to rest position. Okay, so finally object, let's say it is came to rest position. Now what is the question they are asking? How much work is needed? So final angular velocity is going to be 0. So it is rotating at the same time moving forward. So if they gave you velocity of center of mass, that means object is rotating at the same time it is moving forward, because they have already given it is rotating, right? So what kind of energy it will be having? Both the translational and kinetic energy, right? Sorry, translational kinetic energy and rotational kinetic energy. So kinetic energy, final kinetic energy is going to be 0, because final angular velocity will be 0. So initial kinetic energy is 1 by 2 mv square plus 1 by 2 I omega square. Is this a disc or a ring? So it is a disc. Super. As this is a disc, moment of inertia is 1 by 2 into mr square, right? Moment of inertia. So okay, let me substitute values whatever they have given. Mass is 100 kg. Velocity is 20 centimeter per second. It is nothing but 0.2 meter per second. So this value is represented in the form of meter per second as 0.2 meter per second. 0.2 square is 0.04, 0.2 square plus 1 by 2. I is mr square by 2. Okay, so m is 100, r is 2 meter, 2 square is 4 divided by 2 into omega. Did they give angular velocity? No, they haven't given angular velocity. Let me find angular velocity with the help of linear velocity. It can be replaced as v by r, right? So v is 0.2, r is 2 whole square. So it is going to be 0.1 square. 0.1 square is 0.01. Super. So omega is equal to 100 into 0.04 is 4. 2 ones are 2 twos are. We are going to get 2 plus. This is work done. This is not omega. So this is the work required to stop this object. Plus this 4 will get cancelled out. 100 into 0.1 square is 0.01 into 100. It is going to be 1. So total work required is 3 joules. This is the answer. Which option matches? Option B is correct. Let's solve the second question. That is 80. Question number 80. Solution. A solid cylinder of mass 2 kg and radius 50 centimeter rolls up an inclined plane of inclination 30 degrees. Okay, this is inclined plane, angle is 30 degrees, and so they said it is cylinder is being rolled up, right? Okay, so it is represented like this. Okay, so this is an inclined plane and this is a cylinder. So don't ask me how did you represented it is as a circle. So it is extended. Okay, we are just showing the only front view of the inclined surface. If you observe from side, that from the front side, so look at this. This is actually cylinder, right? So if you observe from the top, it looks like only this disc, right? So that's what I'm saying. So this is the view. Okay, next. So what's the mass of this object? Is 2 kg. They said it is a solid cylinder. Okay, angle of inclination is 30 degrees. Radius is 50 centimeter. The center of mass of the cylinder has a speed of 4 meter per second. Super. So it is moving up with an velocity 4 meter per second. Super. The distance traveled by the cylinder on the inclined surface will be, okay, distance traveled by the object on the inclined surface will be, okay, super. So when it reaches maximum height, let's say it is reached to some maximum position, what happens to final angular velocity and final linear velocity? Both of them will become 0, right? That means the final kinetic energy will be 0. As it is reaches to certain height, total kinetic energy, initial kinetic energy of the object is converted into potential energy, right? So let's say it is having only potential energy at this point. So initial kinetic energy is converted into potential energy. Initial potential energy is equal to 0. So we know that according to law of conservation of energy, so energy converted from one form to another form. So here it is according to conservation of energy. Total energy at position A is equal to total energy at position B. Total energy at position A, total energy at position B. What is total energy at position A? Kinetic energy. Total energy at position B is potential energy. Total energy at initial is rotational kinetic energy plus translational kinetic energy. Then only it is possible for me to displace that cylinder to a certain height. So we are by rotating, it is said here, it is rolls up. Okay, so it is rotating at the same time moving up. So it is going to have total translational kinetic energy plus rotational 1 by 2 mv square plus 1 by 2 I omega square, which is equal to potential energy mgh. Did they give angular velocity? No, they haven't given. If they didn't give angular velocity, try to convert that in the form of linear velocity. 1 by 2 mv square plus moment of inertia of solid cylinder is m r square by 2. It is similar to moment of inertia of the disk, omega square. So we know that v is equal to r omega, right? And omega can be replaced as v by r. Let me substitute that. V square by r square, which is equal to mgh. So r square will get cancelled. Now 1 by 2 mv square plus 1 by 4 mv square is going to be 3 mv square by 4, which is equal to mgh. M will get cancelled. Now I need h from this. H is equal to 4g by 3v square. 4 into 10 divided by 3 into, what's the value of v? V is the linear velocity, which is 4 square. So 4 will get cancelled. It is going to be 10 by 12. So this is the height only. I need distance traveled by this solid cylinder on the inclined plane. Let's say that is going to be L. So from this triangle, use sine theta and try to find out the answer. Sine theta is equal to opposite by hypotenuse. So from this L is equal to h by sine theta, which is equal to h is 10 by 12, sine theta is 1 by 2, theta is 30 degrees, right? Okay, that theta is 30 degrees, sine theta is 1 by 2, the 2 goes to numerator. So it is going to be 20 by 12. 20 by 12, 4 3s are 4 5s are. So 5 by 3 is the answer. 5 by 3 we are getting wrong answer. We did substituted wrongly. Here we can observe this. There is a small mistake in this substitution. Here it is. In this case, h is equal to 3v square by 4g. We substituted in opposite. So it is 3, v square is 4 square divided by 40. 4 into 10. So 4 will get cancelled. It is going to be 12 by 10. So from this, h is 12 by 10 into sine theta is 1 by 2. It is going to be 5. So 12 by 5 is the answer. It is going to be 2.4 meter. So which option matches? Option C is the correct answer. Next, hope you understood. So small mistake, even though we did this much, that small misconception changed the answer itself. Okay, so question number 81. In question number 81, what's the question they're asking? A solid sphere is in rolling motion. If it is in rolling motion, what kind of energy it will be having? It will be having both translational kinetic energy and rotational kinetic energy. So what kind of object is this? Solid sphere. Okay. In rolling motion, a body possesses translational kinetic energy as well as rotational kinetic energy simultaneously. The ratio of translational to rotational kinetic energy, rolling kinetic energy they are asking. Okay, super. Kt by Kt plus Kr. Kr represents rotational. Kt represent translational kinetic energy formula 1 by 2 mv square 1 by 2 mv square plus 1 by 2 rotational kinetic energy is I omega square. 1 by 2 will get cancelled out. mv square divided by mv square plus moment of inertia of a rotating object which is of solid sphere is 2 by 5 mr square. Omega is replaced in terms of v, so this is going to be v square by r square. V square will get cancelled. Mv square also will get cancelled. So the thing I'm left with is 5 by 7. So otherwise, let me represent one more step. 1 by 1 plus 2 by 5 will be there. Answer is going to be 5:7. Which option matches? Option B is the correct answer for question number 81. Okay, next. Question number 82. Solution. A disk and a sphere of same radius but different masses rolls off on two inclined planes of same altitude and same length. Okay, which one of the two objects gets to the bottom of the plane first? Before solving this question, we should understand one point, that what is the acceleration of a rotating body on the inclined surface. Let me explain you that. So try to understand all the points that I am going to give. Let me consider one object which is rolling on the inclined surface. So angle of inclination of this is theta, radius of the object is r. Okay, so let's say as it is released, so it is released initially. If it is released, what kind of energy it will be having? It will be having only potential energy. When it reaches bottom, the potential energy is converted into kinetic energy, right? So it is having kinetic energy at the bottom. First of all, let me find out velocity with which it is going to reach the ground. So according to law of conservation of energy, initial energy is equal to final energy. That is, initial total energy is equal to final total energy. That is, initial potential energy is equal to final kinetic energy. So let's say height from which this object is released is h. This object is rolling, that means it is having both translational kinetic energy and rotational kinetic energy. That is, mgh is equal to 1 by 2 mv square plus 1 by 2 I omega square. This omega replaced in the form of v square by r square, because omega relation is omega is equal to v by r, then omega square is equal to v square by r square. That is, mgh is equal to 1 by 2 mv square plus 1 by 2 I v square by r square. Here r is capital R square. Okay, super. What about moment of inertia of this object in terms of radius of gyration? Moment of inertia is mk square, right? Moment of inertia is replaced as mk square. We know about this formula, mk square. Let me substitute this. mgh is equal to 1 by 2 mv square plus 1 by 2 m v square into k square by r square. M will get cancelled out. So from this, what about velocity? V is equal to root of 2gh divided by 1 plus k square by r square. This is the velocity with which the object will reaches to the ground. Final velocity of the object when it reaches ground. Okay, super. Now what is the question that I need to understand is, what is the acceleration of the object? Let's say total length of this inclined plane is s or x. So that's your wish, you can take any variables. Let's say total length of this inclined plane is x. X is length of inclined plane. So by using v square is equal to u square plus 2as, we can find out what's the acceleration. Initial velocity is 0. What about final velocity? It is 2gh by 1 plus k square by r square, right? K square by r square. K is radius of gyration, which is equal to 2 times of a into s. S is going to be x, which is length of the inclined plane. So, or else x is the distance traveled by the objects on the inclined surface. Super. This x value I need in terms of h. So from the triangle, if you observe, sine theta is equal to h by x, right? Then what about x? X can be replaced as h by sine theta. Okay, let me substitute this value in this equation. So 2gh by 1 plus k square by r square, which is equal to 2a by sine theta. This 2 will get cancelled, h will get cancelled. Then what about a? A is equal to g sine theta divided by 1 plus k square by r square. So this is the acceleration of the object which is moving on a inclined surface in a downward direction, okay, or upward direction. It depends on the situation. Hope you understood. Remember this derivation or try to remember the formula. Generally, acceleration of the object which is on the inclined plane is g sine theta according to laws of motion chapter. In this chapter, as object is rotating, we are going to take k as also into consideration. Understood? Okay, super. Next, look at this question 82. What's the question they're asking? They're asking which one of the two objects gets to the bottom plane first. That means I have to find out time. So let's say inclined plane height is going to be x. Assume the same thing. V square or s is equal to ut plus half at square. We can use that equation. S is equal to ut plus half at square. What's the initial velocity? They are released, right? Rolls off onto inclined planes. So altitude and length, same altitude. Okay, one is disk, another one is sphere. Okay, disk moment of inertia mr square by 2, sphere moment of inertia 2 by 5 mr square. They didn't mention whether it is a solid sphere or hollow sphere. If they didn't mention, you must consider it is as a solid sphere. Okay, let's say x distance traveled is x and it is 1 by 2 into a into t square. I need to find out time. Time is equal to root of 2x by a into x by a, right? Okay, let me substitute what's the equation of a time here. Root of 2 into x. So we need acceleration, right? What's acceleration? 1 plus k square by r square divided by g sine theta. I have to substitute a in the denominator. That's why 1 plus k square by r square goes to numerator. This is theta is the same for both objects, right? Okay, so same altitude and same length in the sense theta is going to be same, g is same, x is same. So only thing it is going to vary is 1 plus k square by r square. So t is directly proportional to root of 1 plus k square by r square. K is the radius of gyration. What's the formula for k? K is equal to root of I by m. If it is k square, then k square is equal to I by m. Let me substitute this. T1 or T disk divided by T sphere, which is equal to root of 1 plus k disk square divided by r disk. They said radius of the objects, both disk and sphere, is the same, right? Here in the question itself they are given. They are having same radius. It doesn't mean that radius of gyration should be same. So 1 plus k sphere divided by r, sorry, this r square, right? So k square r square of a sphere. Super. Now What's the formula for moment of inertia of a disk? K d square is equal to I by m. Moment of inertia of a disk is m r square by 2. Will get cancelled. R square by 2 will be there. Super. What about K sphere square? So it is equal to 2 by 5 m r square divided by moment by m. Will get cancelled. 2 by 5 r square. Let me substitute these values here, which is equal to root of 1 plus r square by 2 by r square. So root of 1 plus 2 by 5 r square by r square. R square will get cancelled out. Now I am left with root of 1 plus 1 by 2 is 3 by 2. Next root of, it is going to be 7 by 5. Root 7 by 5. Let me represent this. This is represented as 3 by 2 into 5 by 7, which is equal to root of 15 by 14. This is T disk by T sphere. As 15 is greater than 14, I am going to get this value as greater than 1, right? So this is going to be greater than 1. That means TD is greater than TS. That means time taken by the disk to reach the same bottom is greater than time taken by the sphere. So which object will comes first? Definitely sphere. Try to understand. Here time taken is more in the sense it comes later. So time taken is less in the sense it comes earlier. So this much theory is there to understand. Okay, so this is a pure concept. I tried to explain you. Hope you understood. Let's solve next question. Question number 83. So in question number 83, they're asking the ratio of the accelerations of solid spheres rolling down on an inclined plane of an angle theta without slipping and slipping down inclined without rolling. Super. Without slipping in the sense it is rolling. With slipping in the sense it is just moving linearly. That means acceleration of rolling, just now I gave that formula, that is g sin theta divided by 1 plus k square by r square. Super. So acceleration due to slipping is equal to only g sin theta. No need to consider radius of gyration due to slipping. So I did already given what is k square is for a sphere. It is going to be 2 by 5 r square. Here it is. So this is one. K square for a sphere is 2 by 5 r square, which is equal to g sin theta divided by 1 plus k square 2 by 5 r square by r square. It will get cancelled. Then we are going to get 5 by 7 g sin theta, and this is g sin theta. We need ratio, right? Rolling by slipping. Acceleration rolling by acceleration slipping is 5 by 7 g sin theta divided by g sin theta. G sin theta will get cancelled. Answer is 5 by 7. Which option matches? 5:7 is the correct answer. Is it clear? Next, question number 84. In question number 84, they gave a small object of uniform density rolls up a curved surface with an initial velocity v. It reaches up to a maximum height of 3v square by 4g with respect to the initial position. The object is. Observe this question, guys. They have given energies and they are asking height and they are asking what kind of object it is. Super. Simple logic. So initially when it is at the bottom, what kind of energy it will be having? Kinetic energy. When it is at a maximum height, it will be having potential energy because its velocity will become zero, right? So complete kinetic energy of this object is converted into potential energy. So what kind of kinetic energy it is having? It is rolls up, right? As it is rolls up in the sense it will be having two types of energies, that is translational kinetic energy and rotational kinetic energy. Let me represent that. That is 1 by 2 mv square plus 1 by 2 I omega square, which is equal to potential energy. Potential energy is m g h. H value is the maximum height. Maximum height value they have already given it is, which is equal to 3v square by 4g. Super. Let me replace omega also in terms of radius, that is 1 by 2 mv square plus 1 by 2 I v square by r square, which is equal to mg 3v square by 4g. So g will get cancelled out. mv square, sorry, v square also will get cancelled out. Now 2 cancel out, 2 you are going to get. So let me find out remaining thing, that is I is equal to mv square. Now v square will get cancelled out, right? So I'm left with I by r square, which is equal to 3m by 2 minus m. Super. Then I is equal to m r square by 2. It is going to be a disk. So that is the answer. So which option? Option B is the correct answer. That's how we have to decide. Next, question number 85. Let's solve that question. 85. Solution. A solid cylinder of mass 3 kg is rolling on a horizontal surface with a velocity 4 meter per second. Object is rolling on a horizontal surface. Okay. If it is rolling on a horizontal surface, so this is solid cylinder, right? We are seeing only one view. So like side view, so side view we are seeing. Just observe that mass of this object is 3 kg, rolling on a horizontal surface. Its velocity is 4 meter per second. It collides with a spring of force constant. Okay, super. It is going to collide with the spring of a spring constant is also given. Super. K is equal to 200 Newton per meter. Then the maximum compression produced in the spring will be super. So it is work energy power question. So total kinetic energy. So whatever this object is rolling, right? So it is rolling. If it is rolling, it will be having two types of kinetic energy, so translational plus rotational. So when this ball is going to be collide with this spring, so it will move up to this position. That means this spring is going to be compressed to a distance x. When the spring is going to be compressed, it stores energy in the form of potential energy. So total, according to law of conservation of energy, mechanical energy, kinetic energy of a rolling object is converted into potential energy of the spring. So what's the kinetic energy of the rolling object? It is 1 by 2 mv square plus 1 by 2 I omega square, which is equal to potential energy of the spring is 1 by 2 kx square. X is the compression. That's what we have to find out. So here 1 by 2 will get cancelled out. Okay. Super. What about moment of inertia of this solid cylinder? It is m r square by 2 into omega is replaced with v square by r square. R square will get cancelled. Now we are going to left with mv square plus mv square by 2. mv square by 2, which is equal to k times of x square. So which is 3 mv square by 2 equal to kx square. What's the value of mass of this object? It is 3 kg. Velocity is 4. It is going to be 16 divided by 2. K value they have given it is as 200. So it means it is 2 into 200, which is equal to x square. Don't calculate all these things. So keep them as it is. X square can be written as 3 square into 4 square divided by 20 square, right? Then x is equal to 3 into 4 divided by 20. So it is going to be 12 by 20. 12 by 20 value approximately x is equal to 0.6 meters is the answer. So which option matches? Option B is the correct answer. Did you understood, guys? The way how they have given question. Just go through this once again. It's application of work energy power chapter also. So it's the next question. Question number 86. What is the question they're asking? A solid cylinder and a hollow cylinder. Okay, one is solid cylinder, another one is hollow cylinder. Both of same mass and same external diameter, in the sense same radius, are released from same height at the same time on an inclined plane. Both rolls down without slipping. That is, without slipping in the sense rolling. Okay, super. Which one will reach the bottom first? Super. So we know how to decide which one will reach the bottom. So I just before question number 82, so I did give one relation. Time taken to reach to the bottom is t is equal to root of 2x into 1 plus k square by r square by g sin theta. Now let's use that relation. Now we can decide easily. And they said mass is same, radius is same. Now only thing I have to decide, theta is also same, right? So everything is same. Only thing I have to find out is k square. So k square is nothing but I by m, right? Moment of inertia of solid cylinder is m r square by 2, which is equal to r square by 2. Next, k, this is for solid cylinder. Next, k square for hollow cylinder is I by m, which is equal to m r square by m, which is equal to r square. Let me substitute this. So t is t of solid cylinder divided by t of hollow cylinder is equal to root of 1 plus k square is r square by 2 by r square divided by root of 1 plus r square by r square. So it will get cancelled. This is also will get cancelled. We are going to get root of 3 by 2. So here it is root 2. Now this is going to be root 3 divided by 2. So root 3 value is 1.732 divided by 2, which is less than 1, right? Yes, it is. So TSC is less than THC. So time taken by the solid cylinder is less. So that is the reason which one will reach us first. So solid cylinder will reach us the bottom first. So that is how we can answer. Next, 87 solution. Question. A drum of radius capillary and mass m rolls down without slipping. The meaning of without slipping is rolling along an inclined plane of angle theta. The frictional force, super. If you observe this object, for example, it is rolling on inclined plane, right? Okay, let me consider like this. This is an inclined surface and one object is rolling here. So if this object is trying to move with some velocity, this is velocity of center of mass, as friction is present, friction will act on this object in the opposite direction. As friction is acting opposite direction, this is going to rotate. That means some part of translational kinetic energy. So translational kinetic energy is converted into some part of translational kinetic energy is converted into rotational kinetic energy. So it is converted into rotational kinetic energy. So what is the reason? Because friction is acting in the opposite direction. If there is no friction, object only slips down. Which option is correct? Option D is the correct answer. Next, question number 88. Question number 88 answer. The question is, a ball rolls without slipping. Without slipping is rolling. The radius of gyration of the ball about an axis passing through its center of mass is k. Okay. If the radius of the ball b r, the fractional total energy associated with the rotational kinetic energy. The fractional total energy associated with the rotational energy alone. They are asking fraction of total energy with rotational energy. Okay, rotational energy. What's the formula for total energy? Total energy is 1 by 2 mv square plus 1 by 2 I omega square. Rotational energy is simply 1 by 2 I omega square, right? So we know that 1 by 2 will get cancelled. Omega is replaced with v square by r square. So this can be replaced as v square by r square. This is also replaced with v square by r square. So v square will get cancelled out. Now I am left with 1 by 1 plus I is replaced with mk square. That m also will get cancelled. So this is replaced with mk square. This is replaced with mk square. So m also will get cancelled. Now finally I am left with k square by r square divided by k square by r square, which is equal to k square plus r square divided by k square is the answer. Which option matches? Option A is correct. Oh, this is wrong answer. So what is the question they have given? The fraction of total energy associated with the rotational energy. That means they are asking reverse. So rotational energy divided by total energy. Fraction of total energy. Super. So this is going to be k square by k square plus r square. So this is which option? Option C is correct. So whatever the things I replaced is omega is equal to v by r. One more thing I replaced is I is equal to m k square. So after substituting these formulas, I did cancel those variables. Hope you understood. Next, question number 89. Let's solve that. A solid cylinder of mass capital M and radius capital R rolls without slipping. Without slipping in the sense it is rolling. It will be having translational kinetic energy and rotational kinetic energy. Slipping down on an inclined plane of length L and height h. So this is a cylinder, right? Okay. So when it is at the top, what kind of energy it will be having? So it will be having only potential energy, right? Okay. So when it is at the top, it will be having potential energy. When it is at the bottom, what kind of energy it will be having? It will be having kinetic energy. So complete potential energy converted into kinetic energy. So potential energy is equal to kinetic energy. So potential energy is mgh, which is equal to, so what about kinetic energy? 1 by 2 mv square. As it is rolling without slipping, it will be having two types of energies: kinetic energy, translational kinetic energy, and rotational kinetic energy. Moment of inertia of solid cylinder is m r square by 2 into omega square is replaced with v square by r square. R square will get cancelled. Mv square, p square cannot be cancelled here, so r square only gets cancelled, m will gets cancelled, v is the thing I have to find out. So send 1 2 here, it is going to be 2gh, which is equal to v square plus v square by 2. Then 4gh is equal to 3v square. So from this v is equal to root of 4gh by 3. Which option matches? Option C is correct. Question number 89. Is it clear? Very good. Next, let's solve question number 90. Consider a contact point P of a wheel on ground which rolls on ground without slipping. Without slipping in the sense it is rotating. Super. Question number 90. Let me consider a horizontal surface and an object is, then the value of displacement of point P when wheel completes half rotation. Okay, so it is rotating. After completion of half rotation, this point P is going to be at the top. As this wheel is completed half rotation along horizontal, it is going to cover a distance which is equal to half of the circumference of the circle. So this is going to be 2r is the diameter. Now they need a displacement. So displacement is nothing but shortest distance between initial and final position. This is what I need. If it looks like a right angle triangle, right? Now I need to find a displacement which is equal to, so this is point P, right? So displacement is equal to root of pi r whole square plus 2r whole square, which is equal to, did they give r value? No. Yes, they have given. That is equal to 1 meter. Here it is, if radius of the wheel is 1 meter. So r comes outside, then r root of pi square plus 4, as r is equal to 1 meter. Displacement is equal to root of pi square plus 4. This is the answer. Which option matches? Option B is the correct answer. Super. Next question number 91. A solid sphere of radius capital R is placed on a smooth horizontal surface. So I did represent it in the form of diagram, whatever the data they have given. They said one more point, observe that point very carefully. It's a smooth surface. Is there any frictional force? As this is a smooth surface, it's a smooth surface, there won't be any kind of frictional force. If there is no any frictional force, what kind of motion object will be having? It is a slipping motion. Slipping in the sense it will be having only translational kinetic energy. That means it doesn't matter where you are going to apply force, object will move straight line direction only. A horizontal force F is applied at a height h from the lowest point for maximum acceleration of center of mass, which is correct. Okay, look at the option. H is equal to capital R, H is equal to 2 or H is equal to 0. Okay, so they are saying at a height h, so this force is applied. Then what is the relation between radius of this sphere and height h at which this force is being applied? As this is a smooth surface, there is no frictional force, there is no rotational motion. As there is no rotational motion, so doesn't matter wherever you are going to apply this force, object will move with the maximum acceleration on the horizontal surface. That's why there is no relation between h and r. No relation between h and r. The reason is it's a smooth surface, object is having Only translational motion, wherever you apply force, object will be having maximum acceleration. Option D is correct. Okay, next question number 92. So to answer this question, we should understand the translational motion, rotational motion, and combined motion. This one I did already explained in a previous part 3, that means previous session. You just go through that. In a translational motion, each and every point will move with the same velocity in a forward direction, that is with velocity v. So center of mass also moves with the velocity v. When it comes to rotational motion, so that means it is a spinning motion. In spinning motion, particle which is at the top will move forward, particle which is at the bottom will move backward. So particle at this position moves downward, particle at here moves up. Okay, resultant of these two, that means we need to get rolling motion, right? To get rolling motion, we have to add them. If you add these two, so particle at the top will be having a velocity 2v, particle at the center, I mean center of mass velocity is going to be v. A particle, so here center of mass velocity is going to be 0 because it is spinning there itself, right? A particle at the velocity at the bottom is going to be 0. Now what's the question they're asking? A disk is rolling, the velocity of center of mass is vcm. Which one will be correct? Velocity at the highest point is 2 vcm, correct. At the point of contact is 0. Option A itself is correct. Let's check another point. The velocity at the highest point is vcm. No, it is not, because answer is 2 vcm. Next, velocity at the highest point is 2 vcm. Okay, the point of contact is vcm. No, point of contact is at rest position in a rotational motion. The velocity of highest point is 2 vcm, correct. The point of contact of velocity is 2 vcm. No, it is not, because of point of contact which is on the ground is having 0 velocity in rolling motion. Okay, next question number 93. Solution. A solid spherical ball rolls on a table. The ratio of its rotational kinetic energy to the total kinetic energy, rotational kinetic energy to the total kinetic energy, translational plus rotational, it is R. Rotational kinetic energy formula 1 by 2 I omega square. Moment of inertia of solid sphere is 2 by 5 m r square. Omega square is replaced with v square by r square. This is I and this is omega square. Next, so translational kinetic energy is 1 by 2 m v square plus 1 by 2 into 2 by 5 m r square into v square by r square. R square will get cancelled. mv square will get cancelled. 1 by 2 will get cancelled. So it is going to be 2 by 5 in the numerator and 5 by 7 in the denominator. No, 7 by 5 in the denominator. 7 by 5. So 5 will get cancelled. Answer is going to be 2 by 7 or 2 is to 7. 2 by 7 is the answer. Option D is the correct answer. Okay. Next question number 94. In the question number 94, what is the thing they're asking? A solid sphere, disc, solid cylinder, all of the same mass and radius are allowed to roll down on the inclined plane. Then which one will reach us the bottom? We do know the time relation, okay, that is t is equal to root of 2 into x into 1 plus k square by r square divided by g sin theta. That means t is directly proportional to root of 1 plus k square by r square. So whatever the object which is having small k square by r square ratio, that's the object which is having minimum time to reach bottom. Okay, let's start with the each and every object. K square by r square for solid sphere. So k square is nothing but I by m. Remember that. So moment of inertia of solid sphere is 2 by 5 mr square divided by moment of inertia by m by r square is there. Okay, so it will get cancelled out. Now we are left with 2 by 5. 2 by 5 is going to be 0.4. Next, k square by r square. This is for sphere, solid sphere. Next, disk. So for a disk, this is disk. For a disk, k square by r square ratio is moment of inertia is going to be mr square by 2 by m will be there by r square. mr square will get cancelled. It is going to be 0.5. Next, solid cylinder is also will be having same. So this is k square by r square is the same for both disk and solid cylinder. Now if you observe, k square by r square ratio is 0.4 for sphere, and that is the minimum value. So solid sphere will reach us the bottom first. Option A is correct. Super. Next, question number 95. Let's try. In question number 95, they gave the speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding will be. The meaning of without sliding is rolling. Okay, so object is a solid sphere, right? This solid sphere is released from rest. They said it is initially at rest position. What's the height of this inclined plane? Inclined plane height is h. When it reaches bottom, what is going to be its velocity? That's the question they're asking. Okay, super. Now when it is at the bottom, what kind of energy it will be having? Potential energy. When it is at the bottom, it will be having kinetic energy. As it is initially at rest position, initial velocity is equal to 0. So potential energy is converted into kinetic energy when it reaches to the bottom. Potential energy formula mgh. It will be having two types of kinetic energies: translational kinetic energy plus rotational kinetic energy. Translational kinetic energy formula 1 by 2 mv square plus rotational kinetic energy is 1 by 2 I omega square. Moment of inertia of the solid sphere is 2 by 5 mr square. Omega formula in terms of velocity is v square by r square. R square will get cancelled. M will get cancelled. Then 2gh is equal to v square plus 2 by 5 v square. So from this I need v square. V square is equal to, it is going to be 10 gh divided by 7. Then v is equal to root of 10 gh by 7. Which option matches? Option A is correct. Hope you are going through all these numericals, guys. You just go through the way how I am approaching the numericals. See, these sessions are very helpful, so that you will understand how I can proceed during solving numericals. So we are left with some more 5-7 questions in rolling motion, and we left one more concept, right? That is equilibrium of a rigid body. Those questions will solve in the next part. Thank you so much. Have a nice day for listening to this online classes patiently. So see, concentrate on the things which changes your life. Definitely, so whatever the hard work that I am taking here will definitely help you during your preparation. I wish you all the very best, guys. Thank you so much. Have a nice day.